So in this section, we're going to focus on the concept of finding the slope of a tangent. So in advanced functions, what we found was finding the slope of a secant line. So a secant line is when we use two data points. So what I mean by that is if we look at the secant line on the graph over here, I can say this point as my x1, and then my y coordinate would be fx1, and then I can say this coordinate is my x2 and fx2, right? And I can use these in order to find the slope by using the formula fx2, which is y2 minus fx1 over x2 minus x1. So basically, this is how we found the slope of a secant line. So how do you find the slope of a tangent line? So what's different about a tangent line is it passes through one point. So we do not have that 2 point of a secant line. So how are we going to find the slope? So basically what we're going to do is I can say for the data point, this point is x and fx. So those are my coordinates. And for a second coordinate, I can choose, if we zoom in, I can choose a point that's super close to the original point. And I can say, okay, this coordinate of this is x plus h. So h is any number that's super close to that point. And I'm going to say the same thing for the y point. So fx plus h. So if we use those, I can say in order to find the slope of a tangent, I can use the same formula in terms of concept, but apply it to the tangent line. So I'm going to say this as my y2. So it's going to go fx plus h, and then I'm going to use my y1 minus y1, which is fx, over whatever is my x2, which is right over here. So I'm going to have x plus h minus my x1, which is here. So minus x. So if I simplify it, you guys are going to get the formula, which is fx plus h minus fx over x minus x is just going to cancel out, so we're going to be left with h. When you guys often encounter this formula, it's often given in the form of limit as h approaches to 0. So we're going to talk about this later on in the course, but basically what it means is that, you know how we chose a point over here that's super close? So we're basically approximating a point that's close to the original that data point we're trying to find. So this is basically saying h being a really close number, which we can say 0.00001. Much zeros you have, it more approximate it is. So basically we're saying h is approaching to 0. So when it approaches to 0, more approximate it is. So we're basically saying h approaches to 0. We can use this formula in order to find that data point itself. So in order to better understand how to find the slope of the tangent, we can start by solving this basic question that you can encounter. So it wants us to determine the slope of the tangent to the graph of the parabola fx equals x squared at p equal p, where x point is 3 and y coordinate is 9. So we can start by writing out the secant equation in order to understand how secant line connects with the tangent line. So I'm going to start by writing out the formula for the secant line in order to find the slope. So it's y2 minus y1 over x2 minus x1, right? So what are my points in this case? My x1 point will be whatever is given. So we're trying to find the point 3 to 9. So my x1 is 3, my y1 would be 9. So then what are my x2 and y2 points? These actually I explained in the previous concept, where we were explaining the concept. So my x2 is going to be 3 plus any number that's close to that. So that's where we get h approaches to 0. So this can be 0, 0, 0, 0, 0, 1 or whatever. So my y2 is going to be this x point plugged into the original equation. So because when you plug in the x coordinate into the original equation, you will end up with having the y coordinate found out. So I'm just going to say for this, it's f 3 plus h. So when we do that, my y2 point becomes, for the equation, fx equals x squared. If you plug in this x, you will end up with 3 plus h squared. So that's what I'm going to put for y2 point. So I'm going to start with 3 plus h squared minus, what was my y1? It was 9 over x2. I found that to be 3 plus h. What is my x1? Minus 3. So that's what I end up with. So if I simplify it further, 3 plus h times 3 plus h, so I'm going to end up with 9 plus 3h plus another 3h and then plus h squared. I just expanded this right over here. So, and then don't forget the minus 9 at the end, over 3 plus h minus 3. So I'm going to go ahead and cancel a few things out. So I have a positive 9 over here and I have a minus 9. So I'm just going to cancel these out. Over here I have a plus 3 and I have a minus 3. So I'm going to cancel these out. So I ended up with 6h plus h squared over h. So I can take h out for the beginning. So because I have both h's over here, so I'm just going to take that out. 6 plus h is what I left with over h. So what I see here, I can cancel these out too. So my answer would be 6 plus h. In order to understand what we came up with, we set h to be a super close number that is approaching to 0. So if we got a point where it's 6 plus h, we can basically say the value 6 plus h approaches to 6, because basically we count h as to be 0. So you can basically say we concluded that the slope of the tangent at the point 3, 9 to the parabola y equals x squared is 6. In this question, instead of applying secant line formula, I'm gonna go ahead and start right off with the slope of tangent formula that I gave you guys, and it's on your textbook too. So formula there was limit as h approaches to 0, fx plus h minus fx over h. So if you look at the question itself, it wants us to determine the slope of the tangent to the rational function fx equals 3x plus 6 over x at the point 2, 6. So I'm gonna start out by writing what my x1 points are and what my y2 points are. So I'm gonna say my x1 is 2 because that's what's given, and then my y1 is 6. And then I'm gonna go ahead and say my x2 is 2 plus h, and then my y2 is basically x plugged in to the y, the original equation. That's how you get the y. So I'm gonna go ahead and write the actual equation itself too, because it's kind of complicated over there because it's typed out. So it's basically, this is the equation we're dealing with. So I'm gonna start out by saying, again, limit h approaches 0. What is my y2? So that would be this plugged into the original equation. So when I plug in x back into the original equation, I get 3, 2 plus h plus 6 over 2 plus h. So if I simplify it from there, I have 3 times 2 is 6, and then 3 times h over here is plus 3h plus 6. over 2 plus h. If I simplify it even further, I have 6 over here and I have 6 at the end. So 6 plus 6 is 12 plus 3h over 2 plus h. So I'm gonna go ahead and plug this right back in here and see how it cancels out. So I'm going to say limit as h approaches to 0, and then plug in my y2 point, which is 12 plus 3h over 2 plus h minus, what is my y1 point? That's 6 over h. So if I go ahead from that, I can say, okay, over here, in order to make it easier on us, I'm going to do it with a different color. I'm solving only here now. So I'm going to say 12 plus 3h over 2 plus h. So we have minus 6, right? But this is basically saying 6 over 1. In order to put these together, I can say, okay, let me multiply it by 2 plus h. So I'm going to end up with 12 plus 3h over 2 plus h minus 6 times 2 plus h. And then 1 times 2 plus h is just 2 plus h. So now I can put these together. So I have 12 plus 3h minus 6 times 2 is 12, and then 6 times h is 6h, but because we have minus, it also applies to that. So I have minus 6h. So over 2 plus h. So I'm going to go ahead and plug this right back into here. By the way, do not forget to write limit as h approaches to 0, because they will deduct points for that on the exams. So I'm going to go ahead and plug whatever we found, but simplify. We can actually simplify that further. So we have plus 12 over here and then minus 12, so these cancel out. And then I have 3h minus 6h. So what I found to be is minus 3h over 2 plus h over h. So if we solve that even further, it's limit h approaches to 0. So in order to divide whatever we have by h, I'm going to go ahead and multiply it. So negative 3h over 2 plus h times, because we have h, we're just going to flip it and write 1 over h instead in order to divide it. So I'm going to be ending up with limit as h approaches to 0 minus 3h over h 2 plus h. So what I can do over here is I can cancel these h's out, and I'm going to be ending up with limit as h approaches to 0 minus 3 over 2 plus h. When we write limit as h approaches to 0, we basically count the h value as 0. So we plug in 0 for the h that we ended up with. So when you're solving problems like limit problems, your h should be cancelled out and you end up with a number. Not in all cases, but most of the cases, you need to cancel the h. So I'm going to end up with, when you plug in 0 into the h, you don't have to write the limit again because you already applied that condition. So I'm going to end up with negative 3 over 2. So my solution was, either you can leave it like this or you can just write negative 1 over 1.5. They're both the same thing. But your solution will be that, and you can say then the slope of the tangent for the function 3x plus 6 over x, that was our original equation, at the point 2, 6 is going to be negative 3 over 2 or negative 1.5, however they want. So another different type of question that you might see is when they only give you at 1 point, just like in this one. So now they're not giving us coordinates, but they're saying x is equals to 9 in this case. So how do we solve these? So it asks for us to determine the slope of a tangent to fx is root x at x equals 9. So we're going to use the same concept. So our formula is fx plus h minus fx over h. In order to save time, in order to explain it better, we did x1 equals y1 equals, and then x2 equals, and then y2 equals, right? But to be realistic, if you use this formula, you only need y2 and y1. We don't need x1 and x2. But I'll still do it for you to understand. But on the exam, if you want to save time, you can go ahead and just write whatever y1 and whatever y2 is. So I'm going to go ahead and write whatever is x1 is. So my x1 is 9. That's given. So what is my y1? So like I said, in order to find y, I can just plug this x back into the real equation. So my equation is y equals root x, and my x is 9. So then I found y to be 3. So I'm going to say my y1 is 3. Then what is my y2? So basically, because we said x2 is something plus h, so in this number we have 9, so it's 9 plus h, and my y2 would be that equation plugged back into the original equation. So y equals root 9 plus h. And basically I can't take this out just like I did with 9, so I'm just going to write root 9 plus h. So I'm going to go ahead and plug these, whatever I found, back into here. So I found fx plus h to be root 9 plus h minus, what is my y1? My y1 is 3 over h. And don't forget over here to write limit h approaches 0. So after this, it's all simplifying. But if you look at it here, we cannot really simplify. But what we learned in section 1.1, rationalizing the denominator and numerator, we can definitely use that. So what do we need to get rid of here? We need to get rid of the numerator, because in order to simplify, we need to rationalize the numerator. So I'm going to go ahead, because it's a 2-term, I'm going to go ahead and use the conjugate of the numerator. So we're going to end up with root 9 plus h plus, so I'm changing up the sign, 3. And I'm going to go ahead and use the same thing for the numerator as well. So I ended up with limit as h approaches to 0. So root 9 plus h times root 9 plus h, h just comes out, so I have 9 plus h, and root 9 plus h plus 3, and then minus 3 times root 9 plus h. It's just the same things, but plus and minus, so I'm not gonna bother writing it because they're gonna cancel out anyways. And then minus 3 times plus 3, so I'm gonna end up with minus 9 over. So I have h over here, and because I'm going to cancel h at some point anyways, I'm not gonna bother sparing these h's over here. So I'm just gonna say h root 9 plus h plus 3. So what do we see here? I have a positive 9 and I have a negative 9. So these cancel out. So what do I see over here? I have h and I have h over here, just like I said. They cancel out. So I ended up with limit as 8 approaches to 0. I can say here there's 1 left because everything canceled out. And then I left out with root 9 plus h plus 3. So just like we did before, because h approaches to 0, this is the time that we plug in 0 for the h we have left. So I'm going to go ahead and do that. When I do that, the limit itself here drops, so we don't write that anymore. So it's going to be 1 over root 9 plus 3. So what is root 9 comes out of? It comes out as 3, so I have 3 plus 3. So my slope of tangent is 1 over 6. Okay, so the last type of different question that you guys are gonna see in the textbook is determining the equation of the tangent. So it basically wants us to determine the equation. Whenever you see the word equation in this type of problems, like limit problems, it means write it in the form of y equals mx plus b, which we are familiar with from previous courses, previous math skills you guys had. So when solving this kind of problem, basically it wants us to determine the equation of the tangent to y equals x squared minus 3x plus 1 at the point 3 and 1. So we're going to apply the same concept that we did before. So we're going to start by first finding the slope. So we're going to first start by finding the slope of the tangent. So how do we do that? We do the exact same thing that we did before. So we have the equation fx plus h minus fx over h. So what is my x1 point? That is 3. What is my y1 point? That is 1. So I'm going to go ahead and write the x2 and y2 points also. So my x2 point would be 3 plus h, and then my y2 would be that 3 plus h plugged back into the original equation. So I'm just going to write f3 plus h because it's going to be a long equation. So because it wants to y2 first, I'm going to go ahead and simplify y2. So my y2 is going to come out as, when we plug it in, so it's 3 plus h squared minus 3 plus h and plus 1, which equals to, if we simplify it, this is 3 plus h times 3 plus h. So that's going to be 3 times 3, which is 9, 3 times h plus 3 times h again. So that's going to come to 6h plus 6h. And then we're going to have h times h, which is h squared, minus, here we have 3 times 3. So that's going to come to 9. And then we're going to have 3 times h, which is minus 3h. And then don't forget the plus 1 over there. So we can simplify it even further. I have minus 9 over here and then plus 9 over here. So they're cancelled. Other than that, we have to write it as is. So I have right now h squared plus 3h because we had minus 3h over here, and then plus 1. So I'm going to go ahead and plug this right back into the formula. So right now we have limit as h approaches to 0, h squared plus 3h plus 1. And then what is my y1 point? It's basically minus 1 over h. I can cancel these out. So now I have limit as h approaches to 0, h squared plus 3h over h. I can go ahead and take the h out. So I have limit as h approaches to 0, h plus 3 over h. So now I can cancel these out, and I ended up with limit as h approaches to 0, h plus 3. Go ahead and plug 0 for the value h. So we end up with slope being equal to 3. So after doing the first step, your second step is going to be determining the equation of the tangent, which we said basically plug in back into the formula y equals mx plus b. So I already know the m right over here, so I'm going to go ahead and write it over here. So I have the formula y equals mx plus b. My m is 3, so I'm going to say y equals 3x plus b. And I'm going to use the coordinates given in the equation, the question. So it says the coordinates given is 3 and 1. So I'm going to use that. So my coordinates is 3 and 1. So my x is 3 while my y is 1. This is a point that's on the graph already if you use the graph. So I'm just going to go ahead and plug 1 for the y value in order to find b, because right now what I need to find in order to come up with the equation itself is finding the value of b. So I'm going to write 1 equals 3, and my x value for the point given is 3 also, and then plus b. So 1 equals 9 plus b. In order to find b, I'm gonna go ahead and put that 9 to the other side. So now I have 1 minus 9, which is b equals -8. So if I write the whole equation now, it equals to y equals 3x minus 8. And this is going to be your solution.